Angle of elevation. The angle of elevation of an object A from an observer B who is below the level of A is the angle the line AB makes with the horizontal. So let's say we have B then, and A is elevated, so this is our line. So the angle of elevation is the angle the line AB makes with the horizontal. So this is angle of elevation. The object lower than the observer. So here, this will be angle of depression, theta. The angle of depression of an object, example, a boat at sea, on an observer A who is above the level of B, example, on a cliff, is the angle the line DA makes with the horizontal. A man 1.6 meters tall is 10 meters away from a tree 8 meters high. What is the angle of elevation from the top of the tree to its heights? So now we have a man here who is 1.6 meters tall, 10 meters away. So he's 10 meters away from a tree. 10 meters away from a tree that is 8 meters high. So the question now is, what is the angle of elevation from the top of the tree to its heights? Now, we need this angle. So here, this is our angle of depression. So the angle of depression is equal to the angle of elevation. So from this, we can make out a triangle. This will be our triangle then. For theta, they will have 10 meters. This will be 8 minus 1.6 will give us 6.4 meters. We are looking for this angle. Now, you can use tangents to say that tan theta is equals to 6.4 all over 10. Theta is equals to tan inverse of 6.4 all over 10. Theta there will be equal to height of an inaccessible object. To calculate the height of an inaccessible object, we choose two convenient points P and Q in the line of the object, and the distance between the 2 points P and Q is measured. The angle of elevation at the top is also measured. From these measurements, we are able to calculate the height of the inaccessible objects. Working from the ideas of alternate angles, the angles of depression are equal to the angles of elevation. So here, I'll have, this is theta 1, here, this gives me theta 2. From 2 points P and Q, 30 meters apart and in line with a tree, the angles of elevation at the top of the tree are 22 and 32 degrees respectively. Calculate the height of the tree. So let's start by sketching a diagram. I have the 2 points there, P and Q, 30 meters apart. They are found. This is our tree here. Angles of elevation 22 and 32 degrees respectively. So just sketching. This is 22 degrees. Now we're asked to look for the height of the tree. We don't know the height of the tree. This distance we don't know, we call that x. This is the base of the tree. Let's call the peak of the tree T. Now let's consider this large triangle. Here, I'll say that tan 22 degrees is equals to opposite, that is h all over adjacent, that is 30 plus x. Call this equation 1. From here, I have a cross multiply. Height is equals to 30 plus x in brackets tan 22. H is equals to 30 plus x. What is tan 22? 0.404. This gives us h is equals to 12.12 plus 0.404 x. This is the equation 1. Now, let's consider the smaller triangle. Tan 32 is equals to h all over x. Now, cross multiply. H is equals to x tan 32. What is tan 32? 0.625. So h is equals to 0.625 x. Call that equation 2. We have two equations and we can now solve simultaneously. So let's rewrite. I have h is equals to 12.12 plus 0.404x. H is equals to So, let's subtract equation 2 from equation 1. H minus h gives me 0 is equal to 12.12 minus 0.22 x. Let's solve for x in this equation. It says minus 0.22 x is equals to minus 12.12. Divide all through by minus 0.22. 0.22 x there will be equal to 55.1 meters. Now, how do I get h? Just by substituting into equation 2, I'll have h height is equals to 0.625 times 55.1. our height there will be equal to 34.4 meters. This example shows us how we can get the height of an inaccessible object just by looking at the angle of elevation from 2 points.